Severe weather and the tools to forecast and monitor it. This is the focus of researchers at the National Severe Storms Laboratory.
We exist to support the National Weather Service operations in issuing severe and hazardous weather forecasts. So that gets us into theory, gets us into observational tools, gets us into modeling tools that help the Weather Service do a better job.
Improving forecasts has been NSSL's mission since 1964. Today's forecast office reflects more than 4 decades of research and development.
The National Severe Storms Laboratory does research in 3 areas. The first is weather radar. The second is using information from the weather radar in hydrologic models, runoff models, flash flood type things. And the third one is using information from the radar and other things in numerical weather prediction to make forecasts better.
From the original WSR-57 research project, to the development of NEXRAD, to now mobile smart radars and phased array radar, NSSL continues to push the weather research community to the edge of technology. On the horizon is dual polarization, an additional capability that allows NEXRAD radar to send and receive both horizontal and vertical pulses. This new information will give meteorologists a better idea of the structure and type of precipitation, resulting in more accurate forecasts. Looking to the future, NSSL researchers are working on the next generation of weather radar.
So it's time now that we start thinking about what's after NEXRAD. And what we believe is the best candidate right now is electronically steered radar, phased array radar that is much better, much quicker than rotating systems like the NEXRAD.
Phased array radar's unique flat antenna makes it capable of monitoring weather and aircraft simultaneously, with a promise of significant cost savings. In winter and summer, precipitation presents unique forecasting issues. NSSL's work in radar has led to new water forecasting and management applications.
Believe it or not, the radar is going to give us very accurate estimates of rainfall. Think of it as having a rain gauge every kilometer or 2. It's going to change the way we do hydrology.
The lab's third major focus, numerical weather prediction, improves the way forecasters use weather models, especially in severe weather applications. Much of this work is done in the hazardous weather testbed through extensive collaboration with many individuals and organizations, including the Storm Prediction Center and the Norman office of the National Weather Service.
If you think about it, this is the only testbed in the country that focuses on improving severe storm watches and warnings in an operational environment. And of equal importance, it gives the researchers an idea of what the operational problems are that helps them focus their research more sharply on things that matter.
From early storm chasing to Vortex in the mid-1990s to the upcoming Vortex 2 in 2009, as well as ongoing lightning research, NSSL scientists are in the field, measuring the atmosphere and improving our understanding of nature's most violent weather. The laboratory's success can be measured in the number of lives saved. Its legacy through 40 years remains the national network of NEXRAD radars.
We were deeply involved in testing that system, developing that system, proving that it had value to severe weather warnings and forecasts.
NSSL's greatest assets have always been a clear mission and the people who carry it out.
I think it's important to have a cadre of people who are keeping up with the research, doing the state-of-the-art research that's necessary to improve the warnings and forecasts. Having them all in one place so that they can cooperate and work together is why we should have a National Severe Storms Laboratory.